are you doing today?
I'm doing good. Thank you. How are you?
I'm doing quite well as well. Great to hear it.
Great.
So, I'll go ahead and give a little bit of a preface of what we'll be doing before we begin.
Okay.
So this is going to be a scalable distributed systems interview or system design. And for that, we will need some kind of just whiteboarding app in order to chart through our progress. So do you have any preferred setup on your local machine already, or did you want me to just hand you a link to Excalidraw?
So yeah, I think so because I have an interview for tomorrow and I need to do it with Google Docs. So
Oh, interesting. Okay.
yeah, if we can use that, I think it's gonna be a little bit better for me.
Sure, that sounds great to me.
Okay.
Go ahead and just open up one of those and share your screen when you get a chance.
Okay.
Awesome. Looks great.
And here I have the code bunk.
Yeah, no worries. We won't be using that for this. This will be a non-code interview.
Okay.
So we're going to be going through and, I'll give you a quick, 2-sentence summary of the system that I want you to build. And then from that, you'll hopefully be able to draw out some general and non-functional requirements. And then from there, we'll kind of just work forward, going through some topics like API design, as well as doing some logical block diagramming of what the system might look like. And yeah, we'll kind of carry on from there.
Okay, sounds
That all
good.
sounds good. As much as possible, just try to talk me through your solutions, both so you can ideally help yourself get through the problem, as well as help me to assess what knowledge you have. So, oh yeah, and feel free, if you're already familiar with, the problem, feel free to ask for another one as well.
Okay.
But yeah, the task for today is essentially that I want you to design an online programming practice website. So similar to something like LeetCode, the ask here is that we have users who are each associated with a unique account that they can sign into, sign up for, etc. Be able to find programming practice problems that are relevant to them. And once they have found one that they find particularly relevant, they'll be able to open up the problem and essentially view an online code editor with a pre-templated solution on the right and the prompt on the left. They'll then be able to fill out a solution to the problem in the given pre-written code skeleton, and they'll be able to either test it against a custom test case, which will be just a set of inputs, or once they feel confident, try to submit, at which point it'll run it against a series of 20 test cases. If they manage to successfully pass all 20 test cases, they'll then see a display of the statistics of their solution, which include a percentile both for runtime and space usage of where their solution falls against the other solutions that have been submitted by all other users for that problem.
Okay, sounds good. So, so out of that, I would say problem definition is creating website to do online coding exercises as like LeetCode, right? For example.
Yeah, absolutely.
Okay. So then we can, that's like the high level problem definition, which supports different users and languages and provides various practice topics and gives statistics, that's feedback about time and space complexity on the submitted solutions. So that's what I got, right? So
yes, that sounds perfect.
okay. So here we can talk about assumptions and requirements. Then here we could talk about probably assumptions. Here I would do them. Set functional requirements and non-functional requirements. Okay, so you already mentioned tons of them. So let me let me see. So we need to support users. So we will need to support registered form for a user to enroll in the system, right? And probably we can have two types of accounts, one that's free and another one that has a premium. Is that correct?
No need to consider a premium account for now. We'll just assume that
Okay.
it's either they are logged in or signed up. Actually, yeah, assume that they need to be logged in and sign up in order to experience the site, but there's only one type of account.
Perfect. Users have been already registered and logged in the system. Okay, so that's one. Then they are already authenticated and they are going to search for a topic, right?
Mm-hmm.
And they would need to see a list of problems associated to that topic. That's something we want to implement.
Yeah, absolutely.
Okay. Search for topics, problem topics. And then the user, are we going to need to support various levels of difficulty, like easy, medium, hard?
Yeah, great question. So let's assume that when we say search for problem topics, they should either be able to search by the title of the topic or filter by some number of tags. So yeah, those tags can include, let's just say easy, medium, or hard difficulty, as well as what type of question it is. So something like graphs or dynamic programming, something like that.
Okay, so tags are used to classify type of problem and difficulty. So search for problems using tags and name and description of the problem, something like a word, right? That's description of the problem. Okay, now once the user has the list of problems, the user can select one, and then it can. Are we supporting different languages or?
Yeah, absolutely. Let's say we support a static list of 15 different languages, and we support the same languages for every problem.
Okay. System needs to support 15 languages. For every problem. Okay. And then let me think. So we are going to evaluate time and space complexity. That means as when we manage the system, we should be able to specify how fast the solution needs to, after how long the solution needs to time out, right? Things like that. For example, if it's a system where I want to evaluate a linear solution, then I need to be able to configure that for a given problem, it needs to time out in 100 milliseconds, such that the user can need to provide a better solution that runs under that time constraint. Same for memory. Is that correct?
Yep. So it would need to support that. Let's say each test case is going to have its own restrictions on space usage and runtime.
Okay. So for every problem, the system needs to support independent time and space complexity requirements. Need to support independent for each test case. Okay. And then okay, so the system, you already mentioned that. The system needs to, when the user submits, actually, user can test custom scenarios prior to submit the solution. And then you already mentioned that here that the user, once a problem is selected, a template in the chosen language is going to be presented, right?
Yep.
Sent to the user. Okay. And then user can test custom scenarios prior to submit solution. And then when the user submits the solution and gets some sort of graded with time and space consumption statistics, something like that. Statistics, how much CPU, how fast it ran, how much memory it consumed, and statistics about how the solution is compares to other solutions submitted by other users, right? I assume.
Yep. Totally makes sense.
Statistics compared to other solutions. Okay. And then finally, I think, will we have like a list of, you know, like in lead code, you have a list of top submissions or comments or things like that. Do we want to support that, or that's something?
No need for that in this version.
Okay. Okay. So if you agree, I think with this we have enough, or do you think we are missing something important?
No, I think that looks perfect.
Okay. So for non-functional requirements, I assume, and okay, so here we would be talking about our design, right? So this would be the design, and then probably here we have another topic if there's time, and here we would have things like security, logging, monitoring, and alerting. What else? Cost savings. I don't know. Various things that need to be present, right, in a real system, if we have time. In the design phase, we would need to talk about, or you already mentioned that, but it would be like architecture diagram where we depict the flow, the high level flow. Yep. And then we can probably focus about the, for every component, the API and data model design. And then probably we can do some capacity estimation and scaling, and then probably, I don't know, error handling, like if we want to have different data centers and how we are going to fail over and things like that. So, okay, so about non-functional requirements. So what could be the base, or how many active users should we support at any given day, for example?
Yeah, so let's imagine that we have about 10,000 daily active users.
Okay. So, okay, so we want as well highly available system, right? So available, I assume available system. So we want low latency, right? We want it to be low latency with high throughput. I assume those are requirements, right?
Yep, that sounds great.
High throughput. We will have an active user count of 10,000 daily users.
Yep.
Okay. Now, so from here, I can make some assumptions, but so let's say every user solves two different or three different problems per day. Does that sound fair?
I think 3 sounds ideal.
Okay. Every user solves 3 problems per day. So total problems solved be 3,000 per day. And then let's say the average user takes 5 attempts to solve the problem.
Sure, yeah, I think that sounds great.
Okay. Okay. Average user. So takes 5 attempts. Solve the problem. And then how many, do you have a number in mind of how many problems we already have in our database?
Yeah, so let's say that each we have about 5,000 problems in our database, and we're not for the purpose of this problem, it's just a static set of problems.
Okay, perfect. So this would be here, static set of problems. Okay. Okay, and then for 15 languages. Okay, so I think this would be enough for non-functional requirements. So we have, it's a highly available system. It's low latency. So we're talking about if we need to no, so it's static. So low latency with high throughput and the active user count, 3 problems per day. Okay, so I think this is enough, unless you think I'm missing something.
I think that looks sufficient.
Okay. So here I'm going to add, I'm going to start with the diagram. So so here we would have like an user. I'm gonna use this one. So this would be the user. So we would have the user. We would need to have, probably we won't get into details about this, but we would need some sort of gateway in the middle to do throttling, to do caching, security, and all this stuff. So this would be gateway. This one, I don't know how to. Second. So it's here. So we would have a gateway. And okay, so the way I think of this is we would need to have a service where we have a list of problems, right? The problems have, we would have, this is like the catalog, the problem catalog service. Here we would have the list of problems we have and the tags and all that stuff. And probably we want the search part to be fast. So there are two options. We could either have the user search for problems using this problem catalog, or we can split things. Now, if we use this service, I would separate it. So if we concentrate here, the creation of the problems, the management of the problems and the searching, probably down the road, we could have a higher demand of users. So we're talking about static 5,000 problems, right? Which means we won't be adding thousands of problems every day. So the load that this service would handle, it's very low in comparison with the number of searches we will have per day. So what I think is that we should separate the management of the problems with the searching of the problems. So we should have a search service that the user or that the user interface, we would have a web page, right? Can use to search and display results. Now I would separate it into microservice. This would be for handling the catalog, and this one would be for searching. Now let me see. So now once the problem is selected, then we need the details of the problem, right? So probably the details of the problem, it could be done here. So what I'm gonna do is, and it could be the same thing. So probably this problem catalog can be split into different systems. So one would be problem retrieval, where, and this would work once you have selected a problem. You could communicate to this one and get, using an identifier, the exact template for the problem for a specific language. And this one would be used by the system administrator or the operators of the system to handle the catalog. So here we would have two actors. This would be, I don't know how to, here, it would be the system administrator. And the other actor would be the user, right? The user that is sorry, I think I need to practice a little bit more with this, with these tools. Okay, so this would be the system administrator and this would be the final user. Now I'm going to focus, I'm going to leave this apart. Probably we only need to specify how they're going to be stored. And I'm going to focus more on this part. I'm not done yet, but this would be the user, right? The end user. So the system administrator would create problems and would fill in the template for each language. And then we would have a store, a database here. Now, for the database, what makes sense to me is probably a relational database for the problem catalog, because we are going to be doing search. Well, we will have a search engine here, but I think it could be probably the templates are non-structured, so probably a non-SQL database would make sense, and it could be shared between these two systems. So this would have write access to the data store. So let me add here a data store. So this would be the data store, which would be here, and here probably we could have there are two ways. Both of these could have a connection to this database. So we would have here, but this would be a read-only connectivity, and this would be a read-write connectivity. And now probably what we can do is to use an active-passive replication in which we have read replicas, so we can scale horizontally, and we can route this to the read replicas because it's read-only operations, and we could scale independently this one from this one. And yeah, so the only problem there is that we would be dropping a little bit consistency, such that latest problems that we are adding may not be available right away, but I think that's something we can afford, and it's not going to happen all the time, right? So
Definitely agreed.
okay, so the user here could come and search for problems using the search service, and once they are displayed, it selects one, the guest selects one, and goes to program retrieval service to get the template that comes from the data store and displays that, right? So now the user needs to fill in some code, and so this could be, I don't know, execution service. And in this one, the user submits the solutions, and this execution service compiles the code, and executes the code and gives back results to the user. So yeah, at the high level, I think that would work. Now let me think. So we will need to keep track of the user history and the statistics of all the problems solved. So probably that could be part. We would need as well user service and other things that I will add here. And probably we'll have independently here another service, which could be user execution service. And in this one, we keep track of everything that the user has submitted and so on. And this one, the responsibility of the execution service would be only to execute code for a given user and give back the results. And it could have two endpoints, right? One for test a custom scenario and the other one for submit a solution. The one that submits a solution, what it would need to do is to start up an execution environment and get back statistics about how the problem was solved, and then give back the results to the user, and also send to the user execution service user history service. History service, the statistics, such that later the user can come back and see, okay, how many problems I have solved, what's the code, and so on. Oh, in addition, probably we want to keep history, right? So when we retrieve the problem, probably we want to load the last execution that the user submitted for that problem, and probably we want to store just start coding, and you want to save temporarily every 5 seconds or every 10 seconds. You want to store it, right? So in the case the user closes the browser and comes back again, the user can resume where the user left. So does that sound something we want to support?
Yeah, that sounds great.
Okay. Okay, so I think probably the execution service is where we should focus.
Totally.
I mean, we should focus on any part. So I think this is like the most interesting, probably the search service as well, but which one do you want us to?
Yeah, I agree with that assessment. I think the execution service is the most important to focus on here.
Okay, so let's say, so this would be the architecture diagram. So for the execution service, we already said that execution service. We already said we would have an API, API to design and data model. So for the API, we already said that we need one that is, so it's execution service. So we would need one to test a custom scenario. So we would have like a context path, which would be execution service, and custom scenario. So I'm thinking about having a RESTful interface. I think it makes sense, but probably we could use any technology, right? Like gRCP, or we could use anything, but I'm going to design it as a RESTful web service. So we would have this endpoint, which would be test custom scenario. And in addition, we would have the other one, which is submit solution. So those are the two main endpoints I can think of. Submit solution. Now, for the test custom scenario, we would have an endpoint, which would be a post execution custom scenario. And the parameters we would need would be, I'm sorry, it's, yeah. So parameters, request parameters, would be probably user ID, problem ID, and we would need the code, right? Now the code, it's going to be a text. So we may need to enforce a limit on the amount of data we allowed the user to submit. But if we disregard that for sake of time, so let's say we just add just the text, just a bar chart of 1,000 characters, and it's going to be compressed using gzip. So the payload, and probably we can use also, we will use HTTP2, which also compresses headers and so on. So I assume the final length of the payload won't be that large, right? So, but anyway, we would have the text here, and the problem ID, we would need as well the language ID, because we are going to compile it using a specific language, and the text, which would be the code, right? The user code. So I think to start with, oh, and as it's a custom scenario, then we would need a string that specified the input test case, right, from the user. And then the response code, sorry, this would be the request. And of course, with regular headers, right? Accept header, authorization header with the bird token, I don't know, OTC, JWT, any authorization mechanism, probably a conversation and correlation ID, and so on. So all the standard headers. For responses, the regulars, right? So we would need an HTTP response code. Probably we would need as well a response body in case there's an error. And I think here, I would handle everything, of course, unless it's a an error in the request itself from the client, which would be causing a 400 error, or it's an internal server error, which is a 500. I would handle everything in the 200 range. So here we would need, because the request it succeeded, and in the body of the request we would need to give back the result, probably a result, and probably we would need a result would be succeeded, some sort of cases like failed, partial failed, something. No, this would be succeeded or failed, something like that. And in addition, we would need probably a specific message indicating the exact error, right? Because probably it ran out of time, or probably it didn't compile. So here we would have a specific error message indicating what went wrong. So, but everything with that 200, because the request was actually it was actually served. So that's the way I think of it right now. Now, does it make sense so far?
Yeah, I think it's totally
Okay.
makes sense.
Okay. Now the submit solution would be again request pause. Probably here we would have solution submission, and here we would need as well. It would be practically the same thing, and the only difference could be the input test case. We are not going to receive an input test case. And here probably we will need a little bit more elaboration in the response. So in the response, we may need to return probably a result, a message, an optional message, and probably a list of failed cases, or probably we want to restrict this to the last failed case, to the first failed. Yeah, probably we want to execute every single test case, but just stop at the moment we fail a single one, to stop consuming processes in the service, right? So if we want to give a better user experience to the guest, probably we want to execute all of them and then give back, hey, this is all the test cases that you failed. But if we want to save resources and let the application scale better, probably we want to stop at the very first one and just return the very first fail case, which could be represented. Probably it's going to be more complex, and the final structure is test case ID and a description of the input and what's the output from us. So yeah, so let's do it that way. So it could be a fail case, and this could be an object here which gives back a description, probably a description of the test case that failed, and then probably the input, which here we would just return a string, and then probably the specific error message, which actually should be the same as this one. So probably this is enough, right? Probably this is enough. And then, yeah, so I think this should be enough for that. Do you agree?
Yeah, I think that sounds totally fine. Yeah, feel free to continue on to the data model.
Okay, so for the data model, I don't know if we should focus on the data model of the problems, or you want us to go to how this would work and how we could scale, because here I'm thinking we should have like a set of workers, and each worker could need to have an environment, execution environment per language. And so we could focus a little bit on the data model for the data store, or we could jump into how this service could work under the hood and talk about capacity estimation. What do you prefer?
Sure. No need to dive too deep into the capacity. Sorry. No need to dive too big into the capacity estimation right now. But I would like to hear a little bit more about what you mentioned about the workers and how you would actually implement the execution service.
Okay. So we have 15. Okay. So we are talking about. Let me just remember a little bit. We are talking about. It's gonna be 3,000 requests per day, right? So if we round, I know we are not going to talk about capacity, but just for me to have an idea of how this should be.
Yeah, absolutely.
Okay. So if we just round that the day has 100K seconds, so actually this load, it's not going to be that much at all, because if we just for quick computation, for quick math estimations, we round and we say that we have 100,000 seconds per day, and we are doing only 30,000 problems per day. So we will have less than 1,000 problems per day, right? It's going to be around 300, I think, problems per day or something like that. So the throughput is not really bad, right? The throughput is not really high. So we are talking about less than 1,000 requests per second. So the way I think we should do it is so this connection between the user and the execution service needs to be synchronous, right? Because we are going to wait for the problem to be solved and executed, and we want to know back the results. So that means this needs to be very it needs to be a low latency service, right? Because we want to execute the code really fast and get back to the user pretty quickly. So probably in less than a second, right? So the total round trip. So that means this service, the way I think of this is we are supporting 15 languages, and every language is going to have a different execution environment. That means we need to have execution environments preset, right? They are pre-configured for to allow a very quick execution. Now, the execution environment needs to know what are the test cases that are going to be executed, and it needs as well to compile the code that is being submitted. So the way I envision this is we will have like so here in the store, we would have the source code, the full source code, and what the guest is actually typing here is just a small section that's going to be inserted into the template, and the entire file is going to be executed by the execution, compiled by the execution service, and it's going to be executed. Now, part of the code that the template has should have already the test cases, the execution of the test cases, and probably the output of a log file to indicate what failed or what succeeded. So the way I'm thinking is, for example, let's say a very simple, the guest gets a class that says solution and a method to implement that receives a solution, public int method, right? And a parameter, string param. And here I keep saying guest, the user has to implement here, this stuff. Now, the way I think of this is that in the storage of the actual template, what we would have is some code that already has a main method. Let's say it's Java. We already have a public static, whatever, main method, static void main method. And this method already has new solution, solution as a new solution. And then it does something like s dot method and passes one parameter and receives an output, int output. And then it evaluates the output, and if output is equal to expected value, then it just probably log file, log info or something. It sends output to a very specific file, right? Using some sort of identifier for the execution. So we need an execution identifier. So, and that way you can, I mean, something more sophisticated than this, but so here we would have another scenario in which we expect this to fail or something. And the final output of this is a very long file with a format like scenario one, input parameters, input params, and then result, and so on, right? Like an array this type of things. Now, the service here, so far, does it make sense?
Yeah, so far I think this totally makes sense.
Okay. So the way I think of this, it is we would need to have environments per language that are already set up. So if we have, for example, a Java execution worker, and we would need to have another set of services that are, I don't know, Node.js execution workers, and so on. Now, when this could be as well, it could be a cluster of workers, right? And each worker can have X number of threads, and it can be, depending on the capacity, we could support, for example, 200 executions per worker, or more, right? Or more like that.
Mm-hmm.
Now, what would need to happen is when we receive a problem, we have the language ID and we have the problem ID. Then we need to go to fetch the problem to get the template. So for that, we could go to them. Actually, no. So this just forwards the execution to the worker, and the worker goes to the worker. How this works? A second. And the worker goes to the problem retrieval service to fetch the template for the language and the problem, right? And we would have as well here, each worker would have a cache, right? So probably here we could have a cache, and it could build some sort of cache aside mechanism in which we first go to the cache. If we don't, this would be an in-memory store and an in-memory cache. If we don't have it here, then we go to the data store. So the problem with this is if there are any update to the service, we may be serving a stale problems, right, here in the worker. But that's solved by setting a TTL right here, such that they are not, they don't live that long, and we could experiment the right amount for the TTL. But if the problems are going to be static, they couldn't change that much. So we could have a large TTL for them here, and that would alleviate the burden in the problem retrieval service, and it would speed up the execution in the worker. So probably the TTL can be 1 day or something. And we could even have like here, every time there's a change, we could end up with a pushing mechanism that when something is changed here, we notify with some sort of pops-up mechanism to the execution service or to execution management service, something like this. And we can pre-populate the cache here to speed up the requests, right? Execution, I don't know, caching service, something like this. So here we could every time there's a change, we just publish it here, and this service gets notified. Oh, I'm sorry, I don't really like this tool.
No worries.
So and it comes here and makes sure that we invalidate the entry in the cache and we update the result if it exists. Now, yeah, so once the user gives the submission to the execution service or the test case, we would need to decide what the service is based on the language, and we would forward the request to the worker, depending on the load as well. So this would need to be load balanced. So here we would have the typical architecture, right? A load balancer and a set of services behind, and the load balancer could use many mechanisms, right? Round robin, least number of connections, and so on. So probably here we want to minimize the number of, we want to distribute the load to the worker that has less work. So probably a least number of connections is a better policy. And the idea would be to try to route the request to the worker that at that moment is idle, right? It has some CPU power to do. Now the worker, what it could need to do is to execute the test, and then give back the results to the execution service. Now, the way I was thinking of this is probably a log file. Actually, not a log file. So we want to speed things up. So it should be done in memory. So all the results should be stored in memory and sent back to the execution service. The problem is if one of them fails, then I think we can afford it because the user experience is not a critical operation. So the user experience could be something like something went wrong and the user just needs to resubmit the problem, right? So we just forward to another execution worker and then we give back the results. So I think that would work. The results could be stored in memory in a data structure like what I showed, which could be a list of test cases and the status and so on. And then they would be sent back in the response to the execution service. The execution service then, we don't want to wait for the user history to return before we give back the results to the user. So probably we can decouple this as well, and we can have here a queue, and the execution service would notify the user history, or even more. So we could return the execution service the results, and the worker itself could notify asynchronously the execution service about the results. That way we would minimize a little bit more the latency, right? So this one, as soon as the results are done, the Java execution worker returns the data. And right before that, it kicks off an asynchronous tasks, returns the results, and then publishes into this PubSub. And this PubSub, basically this user history service. Well, there are several mechanisms here. This one can be polling. From this one could be reading, or another mechanism is this one wakes up and makes a call to user's history service. That's also something that can be implemented. So probably this one can work like this, right? So this one can wake up via an HTTP call, the user history service, which would store the data, which will be available for the user next. I don't know. What do you think so far?
Yeah, I think this is pretty much perfect. I definitely like the pub sub mechanisms. Yeah, I think overall this works very well. Yeah, we're actually just about out of time actually. So I'll just go ahead and call it there and yeah, jump into some initial feedback. But yeah, overall I think this is a really strong interview. Obviously I was quiet for a lot of it just because I did agree with a lot of your implementation here. I am always a little bit skeptical of Google Docs as a format for the interview, but I think it seems at least that you've practiced a lot on this format, so you seem very comfortable with it, which is really good to see. I think especially in the requirements phase, you did a really good job of digging through a really solid set of the functional and non-functional requirements, which I think definitely helped during the actual diagramming part. Specifically, I did really like that you knew what you were looking for in terms of, a highly available, low latency, high throughput system. And while it is easy to kind of, it's very easy, generally speaking, to classify what kind of system you'll be looking for, but it felt like you very much took that into consideration with your implementation of the execution service, which was awesome. I did specifically like the consideration of caching the execution runs. That's not often someone catches that. I also thought it was really insightful that you managed to get the different users and languages part in the problem definition, because that's also something I look for in this question, is kind of digging down into the idea of having multiple languages and how to support that. Definitely pretty often people will miss that requirement and just kind of skip over it, but then their implementation won't quite work when, surprise, there's a lot of different languages. So it's not as simple as having a single compiler running. So I thought that was really good as well. Yeah, I would definitely consider this a strong hire interview. The only thing that I would say is that the layout of the interview that you had specified in the beginning was quite ambitious for a 45-minute interview.
Mhm.
How long, out of curiosity, is your interview for tomorrow?
It's just 1 hour, so
Okay, so it's a little longer.
yeah. To be honest, I really struggle with this format of interviews because I don't know. I don't know. It's like you can go. What do you want to focus on? No, I mean not you, but in general, the company,
Yeah.
right? What do you want to focus on, the details or how you're going to do the solution? If you want to do it correctly, you need time. Or what do you want to focus in on scaling? If you want to do that, you should focus only on that. So I don't know. I struggle with these time constraints, to be honest.
Yeah, so that was gonna be my one feedback that's not necessarily, super negative or anything, but just something to watch out for. The solution to that is just that you have to keep checking with the interviewer. Um, you kind of have to put it on them to tell you what they want and then deliver that. Um, Definitely, I would say shooting for every like 5 to 7 minutes, circling back to the interviewer and being like, "Hey, am I on track? Do you want me to switch to anything else?"
Okay.
And that's just something you have to ask. And a lot of interviewers will be like, "Nope, carry on, you're doing great." But there may be interviewers who are, waiting for you to cover a certain topic because, according to whatever rubric they're grading on, they'll say, "Oh, you didn't get to this, therefore I can't give you a pass." But, you know, it's it is on you to clarify with the interviewer super deeply, like, like I said, every 5 to 7 minutes checking in and being like, "Hey, am I on the right track, or do you want me to move on?"
Excellent. Okay.
And that's kind of the key. I have no doubt as to your knowledge of, at least this question. I think you demonstrated a lot of good knowledge. But I'm also more concerned about, sort of depth of knowledge rather than covering every topic. But that's totally company dependent. So there are companies that you could interview for where you would get, an interviewer that maybe just wants to see you demonstrate knowledge and doesn't require any particular topics to be covered. Whereas other companies are like, well, it's about time management, therefore you have to cover everything. And yeah, they're very different interviews because one of those is going to be, diving incredibly in depth into one thing. A lot like with this question specifically, the execution service is most of the complication with it. So I was quite happy spending a lot of time there. But yeah, it's just something you have to be very constantly checking in on.
Okay. Thanks. That's a great advice. Thank you very much. Yeah.
Yeah, absolutely. Yeah, that was kind of going to be my big point. I would say probably to be a little bit less specific with what you're planning to cover, because I know that at the top of this you had covered, we're going to go over all of these topics in this order. Here's, we're going to discuss data store, and then we're going to discuss possible optimizations. We're going to talk about error logging, error handling. I think it's best not to include those. I would set out a reasonable guide for what you might be able to cover in the interview, just because it makes it feel like you ran out of time more than you did if you list 20 steps in your initial functional and general requirements. Then some interviews might very much expect you to get through all 20 steps, even if you just wrote them out yourself. So yeah, that would be the one point of feedback. I would say stick to really high level topics in laying out what you're going to discuss in the interview, just so you get yourself the absolute best chance of covering all of it. Because yeah, even though it will be 15 or 60 minutes longer than this interview, but it's still something where it's like, I would say shoot for really broad categories. Like, yeah, I'm going to go through requirements, API design, diagramming, data structures, and just end it with that. And then if you have time for other things, then you can add them on at the end separately.
Okay. Yeah. Thank you. That's a good advice.
Yeah, but I mean, otherwise, both your knowledge and your communication, I thought, were really strong. I did very much appreciate all of the clarifying questions you asked at the beginning. I think definitely focus on asking lots of questions very early in your interview, because it does kind of separate you. If you start asking a lot of questions in the first 5 minutes, that kind of separates you in the mind of the interviewer away from a lot of other candidates who are kind of just going to work independently and not make it a collaborative experience. So yeah, definitely how you present the general requirements in the first, 5 minutes is very important. But I think you did a really good job in this. So replicating that flow tomorrow would be great, I think.
Okay. Thank you very much. Thank you very much.
But yeah, we had about 3 minutes left. Did you have any questions for me left before we drop off? I'll be able to provide a lot more detailed feedback in the feedback sheet. But
no, well, no, just one. So it has nothing to do about this system design. So if you
yeah, absolutely. Totally
help,
fine.
okay, thanks. So I was asked to focus on mapping very large data sets to a single value. So I have been trying to investigate and I haven't found anything related to that other than, I don't know, general statistics like standard deviation, the median, things like that map data to a single value. But I don't think that's what they refer to. And it was told me by the recruiter, which is not technical. So do you know what they could refer to?
I could only hazard a guess that it's something to do with like map reduce concepts. Something about, working through large data sets and being able to use some kind of cloud map reduce stack in order to get some kind of averages out of it in kind of a scalable way. So I would maybe take a look at some map reduce concepts and see if that maps on to anything that they do. Just being able to process large data sets on like a cluster using like a distributed algorithm, and being able to use that to get like a summary out of it. That would be my guess. But obviously it's a little hard to tell. So
okay, yeah, okay, makes sense. Thanks for that.
Otherwise, thank you so much. Have a good rest of your day.
Thank you, you too.